When determining the number of conductors permitted in an electrical box, specific rules must be followed to ensure safe and compliant installations. First, it is essential to understand how different components within the box contribute to the conductor count. Switches and dimmers are each counted as 3 conductors. This accounts for the line wire, the load wire, and the ground wire. Receptacles are counted as 5 conductors each. This accounts for the 2 line wires, 2 neutral wires, and the ground wire. For junction boxes, count the total number of wires entering and exiting the box. Single receptacles count as 3 wires, representing 1 line, 1 neutral, and 1 ground. Double receptacles are counted as 5 wires, 2 line, 2 neutral, and 1 ground. Wire nuts are counted as 2 wires each because they connect 2 wires together. To determine the maximum number of wires that can fit in the box, first calculate the total wire count. Add up the number of wires from all connectors, receptacles, and wire nuts. Secondly, subtract the number of ground wires. Ground wires, typically bare or green, are treated differently in the calculation. Thirdly, divide the result by 2. This division provides the maximum number of current carrying conductors that can safely fit in the box. Consider an example. Suppose an electrical box contains 1 switch, 2 receptacles, and 3 wire nuts. First, calculate the total wire count. The switch contributes 3 wires, the 2 receptacles contribute 5 wires each, totaling 10 wires, and the 3 wire nuts contribute 2 wires each, totaling 6 wires. This gives a total wire count of 3 plus 10 plus 6 equals 19 wires. Next, subtract the number of ground wires. Assuming 1 ground wire from the switch, subtract 1 from the total, resulting in 18 wires. Finally, divide by 2. 18 divided by 2 equals 9. Therefore, in this example, the maximum number of current carrying conductors that can fit in the box is 9. It is crucial to consult the National Electrical Code or NEC for specific box fill calculations and requirements, as they vary based on box size, conductor size, and other factors. Always adhere to local electrical codes and regulations to ensure a safe and compliant electrical installation. For a more detailed understanding of box fill calculations, refer to Chapter 3, Wiring Methods and Materials, Article 314, Outlet, Device, Pull, and Junction Boxes, Conduit Bodies, Fittings, and Handheld Enclosures of the NEC. This article provides comprehensive guidelines for proper box sizing and conductor fill. Article 314.16 specifically covers the number of conductors allowed in outlet, device, and junction boxes and conduit bodies. It outlines how to calculate the volume of the box and the space occupied by conductors, devices, and fittings. Understanding the terminology used in NEC is crucial. For example, conductor fill refers to the number of conductors permitted in a box based on its volume and the size of the conductors. Box fill refers to the calculation method used to determine the allowable number of conductors, devices, and fittings in a box. In addition to counting conductors, you must also account for devices and fittings installed within the box. Device fill refers to the space occupied by devices such as switches, receptacles, and lighting outlets. Fitting fill refers to the space occupied by fittings such as lock nuts, bushings, and connectors. To perform a box fill calculation, firstly determine the volume of the box in cubic inches. The box volume is typically marked on the box itself. If it is not marked, consult the manufacturer's specifications or use a box fill calculator. Secondly, determine the conductor fill. This is the total volume occupied by all conductors in the box. Each conductor is assigned a volume based on its size. The NEC provides tables that specify the volume allowance for different conductor sizes. Thirdly, determine the device fill. Each device installed in the box is assigned a volume based on its type and size. The NEC provides guidelines for determining the volume allowance for different types of devices. Fourthly, determine the fitting fill. Each fitting installed in the box is assigned a volume based on its type and size. The NEC provides guidelines for determining the volume allowance for different types of fittings. Fifthly, calculate the total fill. This is the sum of the conductor fill, the device fill, and the fitting fill. Sixthly, compare the total fill to the box volume. The total fill must not exceed the box volume. If the total fill exceeds the box volume, you must use a larger box or reduce the number of conductors, devices, or fittings in the box. For example, let's consider a 4" by 4" by 2.125" metal box. This box has a volume of 30.3 cubic inches. Suppose the box contains the following conductors: 6 number 12 AWG conductors, 2 number 14 AWG conductors, 1 single pole switch, 2 grounding conductors, and 4 cable clamps. Firstly, calculate the conductor fill. From NEC table 314.16 burn, the volume allowance for number 12 AWG conductor is 2.25 cubic inches and the volume allowance for number 14 AWG conductor is 2 cubic inches. Therefore, the conductor fill is 6 times 2.25 plus 2 times 2, which equals 13.5 plus 4 equals 17.5 cubic inches. Secondly, calculate the device fill. From NEC 314.16b4, each single pole switch counts as 2 conductors based on the largest conductor size connected to it. In this case, the largest conductor size is number 12 AWG. Therefore, the device fill is 2 times 2.25, which equals 4.5 cubic inches. Thirdly, determine the grounding conductor allowance. According to NEC 314.16b5, all equipment grounding conductors in a box are counted as a single conductor, based on the largest equipment grounding conductor entering the box. Assuming the grounding conductors are number 12 AWG, the grounding conductor allowance is 2.25 cubic inches. Fourthly, determine the fitting fill. According to NEC 314.16b2, each cable clamp counts as 1 conductor, based on the largest conductor size entering the box. In this case, the largest conductor size is number 12 AWG. Therefore, the fitting fill is 4 times 2.25, which equals 9 cubic inches. Fifthly, calculate the total fill. The total fill is the sum of the conductor fill, the device fill, the grounding conductor allowance, and the fitting fill. In this case, the total fill is 17.5 plus 4.5 plus 2.25 plus 9, which equals 33.25 cubic inches. Finally, compare the total fill to the box volume. The total fill of 33.25 cubic inches exceeds the box volume of 30.3 cubic inches. Therefore, this box is overfilled. To correct this situation, you would need to either use a larger box or reduce the number of conductors, devices, or fittings in the box. Another important consideration is the use of listed boxes and fittings. Listed products have been tested and certified by a recognized testing laboratory to meet applicable safety standards. Using listed boxes and fittings ensures that they are suitable for their intended use and that they will provide adequate protection against electrical hazards. When selecting boxes and fittings, pay attention to their listing information. The listing mark will typically appear on the product itself and will indicate the name of the testing laboratory and the applicable standards to which the product has been tested. In addition to box fill calculations, you must also consider the physical limitations of the box. Do not overcrowd the box with conductors, devices, or fittings. Overcrowding can make it difficult to install and maintain the wiring and can also increase the risk of electrical hazards. Ensure that there is sufficient space within the box to allow for proper conductor bending and termination. The NEC specifies minimum bending radii for conductors to prevent damage and ensure proper insulation. When installing conductors in a box, be careful not to damage the insulation. Damaged insulation can create a path for electrical current to leak, which can lead to electrical shock or fire. Use appropriate tools and techniques to strip the insulation from conductors without nicking or cutting the conductor. When making connections in a box, use listed connectors that are suitable for the type and size of conductors being connected. Ensure that the connectors are properly tightened to provide a secure and reliable connection. Loose connections can cause overheating and can increase the risk of electrical hazard. When installing devices in a box, follow the manufacturer's instructions carefully. Ensure that the devices are properly mounted and secured to the box. Loose devices can vibrate and can cause damage to the wiring or the device itself. When installing covers on boxes, ensure that the covers are properly secured and that they provide a tight seal. Covers help to protect the wiring from dust, moisture, and other contaminants. Damaged or missing covers can increase the risk of electrical hazards. Regularly inspect electrical boxes and wiring for signs of damage or deterioration. Look for cracked or broken boxes, loose connections, damaged insulation, and other potential problems. If you find any problems, have them repaired by a qualified electrician. Proper box fill calculations are essential for ensuring the safety and reliability of electrical installations. By following the guidelines in the NEC and using listed boxes and fittings, you can minimize the risk of electrical hazards and create a safe and code-compliant electrical system. Remember to consult with a qualified electrician if you have any questions or concerns about box fill calculations or other electrical work. They have the knowledge and experience to ensure that your electrical system is installed and maintained safely and correctly. For example, consider an octagonal box that is 1.5 inches deep and 4 inches wide. This box has a volume of 12.5 cubic inches. Suppose the box contains 4 number 12 AWG conductors, one device such as a lighting fixture, and 2 equipment grounding conductors. Firstly, calculate the conductor fill. From NEC Table 314.16 bone, the volume allowance for a number 12 AWG conductor is 2.25 cubic inches. Therefore, the conductor fill is 4 times 2.25 equals 9 cubic inches. Secondly, calculate the device fill. According to NEC 314.16b4, each device such as a lighting fixture counts as 2 conductors based on the largest conductor size connected to it. In this case, the largest conductor size is number 12 AWG. Therefore, the device fill is 2 times 2.25 equals 4.5 cubic inches. Thirdly, determine the grounding conductor allowance. According to NEC 314.16b5, all equipment grounding conductors in a box are counted as a single conductor, based on the largest equipment grounding conductor entering the box. Assuming the grounding conductors are number 12 AWG, the grounding conductor allowance is 2.25 cubic inches. Finally, calculate the total fill. The total fill is the sum of the conductor fill, the device fill, and the grounding conductor allowance. In this case, the total fill is 9 plus 4.5 plus 2.25 equals 15.75 cubic inches. Compare the total fill to the box volume. The total fill of 15.75 cubic inches exceeds the box volume of 12.5 cubic inches. Therefore, this box is overfilled. To correct this situation, you would need to either use a larger box or reduce the number of conductors, devices, or fittings in the box. Always check the manufacturer's specifications for the volume allowance of each electrical box. These specifications are important because the volumes may vary. Also, boxes marked with a volume are the only ones acceptable to use for these calculations. Article 314.15 covers the damp or wet locations for boxes. In damp locations, the boxes and fittings must be placed so to prevent moisture from entering or accumulating in the box. In wet locations, the boxes and fittings must be listed for use in wet locations. The support of boxes is covered in Article 314.23. Boxes are required to be securely fastened in place. The method of support will depend on the specific application and the type of construction.